Here we have a math Olympiad problem. There is a square root of x. Again, we have a square root inside the first square root x. So again, we have square root x equals to 3, and we have to solve for x. That is, we have to find the value of x. Okay, here we have the first square root completely for this stuff. And if I want to write a square root as an exponent, I can write it, but it will be 1 over 2. So you can change the square root as exponent, then it will be 1 over 2. So since we have square root for this complete stuff, I can write the first square root as an exponent, that is 1 over 2 for the stuff we have over here. So x times square root of x times square root of x whole to the power of 1 half equals to 3. Okay, here we can consider the rules, exponent rules over here. So, for example, we have two quantities a and b are multiplied, and we have the common exponent m. So, whenever two quantities are multiplied and we have the common exponent, this exponent can be distributed to each quantity and multiply them. That is a to the mth power times b to the mth power. So, here you can consider this x as one quantity, this square root of x as another quantity. So these two quantities are multiplied, and 1 over 2 is a common exponent. So this common exponent can be distributed to this quantity, and we have to multiply them as a exponent over here. Actually, this is one of the rules of exponents. Okay, now let's distribute the exponent 1 over 2 to this one and this one. When I do so, I'll be getting x to the power 1 half square root of x whole to the power of 1 half equals to 3. Okay, here we have square root over here for this complete stuff. So we can write this square root as exponent, that is 1 half for the stuff we have over here. Okay, let me do it in the next step. X to the power of 1 half x times square root of x. I am writing this square root as exponent, then I'll be getting 1 half to the power 1 half equals to 3. Okay, here x to the power 1 half. So here we can use the power of a power rule in exponent. So here for the base x times root x, we have exponent 1 half. And for this complete stuff, we have the exponent 1 half. Whenever we have two exponents like this, we can multiply the two exponents. So then I'll be getting x times square root of x. When I multiply these two exponents, that is, I have to multiply the two fractions 1 over 2, 1 over 2, 1 times 1 is 1, 2 times 2 is 4. I'm getting 1/4 equals to 3. Here 1/4 is a common exponent for the product x and square root of x. So as we have already discussed over here, it's one of the rules of exponents. So that is, whenever we have common exponent for a product of two or more quantities, we can distribute the exponent to each quantity and we have to multiply them. So then we get x to the power 1 half times x to the power 1/4. When I distribute this exponent 1/4 to this x, it will become x to the power 1/4 times square root of x to the power 1/4 equals to 3. Okay, here we multiply two terms with the same base, so we can write the base ones and we can add the exponents. This is a product rule of exponents. Whenever we multiply two or more terms with the same base, we can write the base ones and we have to add the exponents. And here we can write this square root as an exponent, then I'll be getting x to the power of 1 half. Already we have exponent 1/4, which is equal to 3. Okay, x to the power 1 half positive 1/4 times x to the power. So here we have two exponents. So whenever we have two exponents like this, we can multiply the two exponents. So 1 over 2 times 1 over 4 will be 1 over 8 equals to 3. So here we multiply two terms with the same base x. So we can write the base ones and we can add the exponents. 1 half positive 1/4 positive 1 over 8 equals to 3. Okay, let me continue this stuff on the next page. So we have x to the power of 1 half over 1/4 positive 1 over 8 equals to 3. Okay, now we have to simplify this one. So that is, we have addition of three fractions. Whenever I add two or more fractions, I need to have the same denominator, so that I can take the denominator once and I can add the numerators. So here, to get the same denominator, so look at the three denominators, 2, 4, and 8. So the least common multiple of these three denominators is just 8. So that is, we have to get each denominator as 8. For that, I have to multiply the first fraction 1 over 2 by 4. That is, I have to multiply both numerator and denominator of this fraction by 4, so that I'll be getting 8 as denominator. So when I multiply the numerator 1 by 4, it will be 4, and when I multiply this 2 by 4, it will be 8. I have to multiply the numerator and denominator of the second fraction by 2, then I'll be getting 2 over 8. I keep the third fraction as it is, okay, so equals to 3. So now I got the same denominator. I can take the denominator once and I can add the numerators 4 positive, 2 positive, 1 equals to 3. So x to the power 7 over 8 equals to 3, because 4 plus 2 6, 6 plus 1 7. But my aim is to solve for x, that is to find the value of x. So I don't want this exponent 7 over 8. So to get rid of this exponent 7 over 8, I raise both sides to the power of 8 over 7. Okay, here as we have seen already, we can multiply the two exponents over here. So 7 over 8 times 8 over 7 equals to 3 to the power 8 over 7. So this 8 will cancel, this 7 will cancel out. I just x to the first power. X to the first power is just x. So we get x equals to 3 to the power 8 over 7. So now I solve for x. The value of x is 3 to the power 8 over 7.